Hi, welcome back to the channel. Topic for today is to cover HTTP sessions, cookies, and how we implement something like user login flow in a Clojure web application. So the first part will be a bit of theory, and as usual, in the second part we'll implement a simple user login flow, and we'll discuss how sessions work in Ring library. So first of all, as we all know, HTTP is a stateless protocol. So that means that if we have two requests in the same connection, they don't know anything about each other. So the question is how we implement something like user session, right? Because all requests should kind of know that this is the same user. Luckily, HTTP protocol provides a thing called cookies. So a backend or our server can set a response header, which is called set cookie, and then we have a name of the cookie and the value of the cookie, and this information is stored in the browser, and browser guarantees that it will send this cookie header to all requests after this to the server. So we can put some key there, and we on the backend can understand that this key means our user. But yeah, we'll look into details a bit later. So this is quite useful documentation here about cookies if you're interested to read, but we're basically interested in this first. So as I said, we have set cookie header for the response, and we're saying, for example, we have this yummy cookie and this is the value, and after this response was received by the browser, all other requests will have this cookie as a header. So that's good. We also have different lifetimes of cookies. So the basic one will be session. So the browser will basically decide when to invalidate the cookie and delete it. So it usually like when you close the browser or something like that. Also we have permanent cookies, so we can control things like expires attribute and max age to say, for example, we want to store the information about our user in the browser for 30 days. So let's say we want that, and we can say that max age should be 30 days for a cookie. Some security options that good to know, and there are two important things. One is a secure attribute, which is Boolean. We can say true or false. So secure true will mean that the cookie will only be sent by browser if we're using HTTPS connection. And for the local host, it works as well, because localhost is kind of exclusion from the rule. So we can use that property for local development. That's fine. And also we have HTTP only, and that means that your browser will only be able to send this cookie in the request by himself. So like when you trigger a new request from the browser, but your JavaScript will not be able to read content of the cookie. So that prevents something like if you have a script included in your front end that you don't have like full control, and for example it can try to steal cookies if they are not protected with this property. So yeah, that's good enough to start. I suggest we just move to our Clojure application and start implementing things. So first of all, we have this Ring Composure application, and I created some dummy routes here. So we have this login, we have info, and we have logout. Just for demonstration purposes, I decided to use get for all three. Obviously, for things like login and logout, you potentially want a post request, because if you use get, you have to pass your user name and password as a query string, which is not great. But for us, it will be much easier to work from the browser if we don't have to build like a form that will do a post request for us. So we have these three, and we have this info that now implemented to always return no session, as the response. So let's go to info. If I refresh, we have no session. If we go to inspect and then scroll a bit to the storage part, and there is a cookies section, and now you see we don't have any data here, so we don't have any cookies for the localhost 3000. So in Ring we have a useful middleware that's called Ring Middleware Session, and the thing that we want to do is to actually add it here in our middleware list. So it will be Ring Session and then wrap session. And now if we reload, nothing actually changes, but now if we go, for example, to our login endpoint and we start implementing the logic here. So let's say we have, we'll get our credentials from the params. So it will be request, and then we want params, and then we want select keys, and let's say we want user name and password here. That's good. And after that, let's say we want to return status 200 and body. For now, let's just do string of the credentials so we see how it works. And now if we go here, we have query prompts username and password. If we reload, this is returned. But now let's start implementing the flow. So we want, for example, to compare these credentials with something. So if our credentials equals to username test and password test, in that case we want to return something like I'm inside, so meaning that like we have successful login. And in opposite case, let's say credentials are not correct. So let's reload this and restart. So it says I'm inside, but if we do test 1 here, it's not correct. So now the magic of the session middleware. If we I prepared like a user information here. So this branch of if means that our credentials matching something inside our records. So obviously this is a naive solution, but in real world it will be like a lookup in the database by the username or some unique like email or something like that. Your database will most likely store a user password not in a raw format, but in kind of like encrypted format. So as you have this encryption key in your app, the password that was submitted by the user in the login form will be encrypted first, and it will be compared with the encrypted version from the database. So in that case, we know the passwords are the same, but we never store user password in unencrypted form, which is good. But as we don't have database here, I don't want to overcomplicate this tutorial. So let's do this simple approach. And it will be good enough to see how session works. So regarding sessions, we want to pass now this session key inside our response, and I want to pass this user information here. So now let's resend the request. And now if we go to the cookies, as you can see, we have an entry now. So the cookie is called ring session, and the value is some key. And then we have this localhost, and we have a session cookie. So yeah, that's good. Don't worry, we'll see the details of the middleware in a sec. I just want to show you high level first. So now inside this info endpoint, we can actually destructure our request, and we can do keys, and it will be session on the top level of the request. And let's say it will be an empty map or like a real map. Basically, whatever we put here in the session will be stored in a session store, and we'll get this information from this key. So let's say if the session is a sequence, then we say status 200 and body hi and our session. So it's printed, so it's string like that. Let's restart. And if we go here and let's resend this one. Yeah, so as you see, our session is printed here because now we have this cookie, and in the request, when we do the request to this endpoint, if we go to the network tab, as you see, our browser is sending the cookie as part of the request. So it's sending this key, and our backend, we're able to map this key to our session map that we provided in the login. So yeah, let's take a look how the logout works, and it's actually pretty simple. So yeah, as I said, it will be something like post request or whatever, but get will work as well. So the only thing we want to do is to, let's say we have status 200. We don't care about the body really, but the thing that we want to do is just to set a session to nil. And if we reload that and we go here and go do a logout, now if we refresh this thing, we have no session now because the session was deleted in the backend. If we refresh here again, resend this login request, go here, refresh it, and we have the session again. So how that works in more details. So first of all, you need to understand that there is no magic at all in this session key. It's basically just a convenient way to use the middleware, but nothing stops you just to implement it yourself. The only thing you want to provide a header that's called set cookie in your response. Let's take a look what's going on inside our middleware and what params we can configure here. So what it's actually doing is it's using this session key, and then we have we want this session response, and this is the main thing, and we're using the cookie store. There are two options for the built-in ring. So one is a memory store, which is a default, and the other one is the cookie store that could be switched to. So we are using the memory store by default, but we'll switch to cookie store in a sec. So regarding this, the memory store, it looks like this. So the protocol a store should implement is this small thing. So there are three methods basically: read session, write session, and delete session. And for the memory store, it's just using an atom to store your mapping between the cookie key to the data that we put in a session. So to have more control regarding the data that we store, let's configure this thing with, we can say store here, and we can use this memory store, and we can provide, pass there our atom. So let's say we have our custom memory store atom, and we want atom of a map And let's put it right here. Let me restart this. Custom memory store atom. Yep, so it's empty now. And if I resend this request to login, and now see what's inside this atom, you see it's a map, and the key is this UID or whatever, and then we have the session data inside. And if we go to our cookies and we search for this value, this will be actually this key from our atom. So the problem with that approach is that if I reload, restart the app, right? So the atom is destroyed. If I go again into info, we'll get this no session because our atom is not surviving the restart of the application, which is obviously not ideal. One option to fix that is to actually use a different type of store, and it will be the cookie store. So it's also provided by default from Ring. So it will be cookie store. If we just run it without any properties, it will be the same problem. So if I log in here, I refresh, we have it here. The difference now is that if we inspect our cookies, storage, cookies. So now we have this, now we have this cookie, and it's much bigger than it was before. And it's because session cookie store is using our session data, and it encrypts it, and it puts it its encrypted version inside the cookie itself. So we don't store the information on the backend. We just use some crypto key to encrypt or decrypt the cookie body to our data. So, as I said, we have the same problem if we restart the app. We have no session because to decrypt the cookie, we need to use the same key that we used to encrypt it in first place. And luckily, this config that we can say key here. And if we go to the docs, it says that we need a secret key to encrypt our session cookie, and it must be an array of 16 bytes. The one way of doing that is actually to generate it first. So we can generate a random bytes, 16. And one of the ways to pass that between our restarts is we can convert it to a vector, and we can, so it will look like this, and then we put it into config.edn or something like that. And for example, we want to say that it is cookie store key, like that. If we refresh, we'll have a file. Yeah, ID is a bit slow. Yeah, here we go. So we have this file now that like static. So, or it could be a config or something like that. So after that, we need to basically read this key, and we can do it by let's do it in REPL first. So it will be slarp config.edn, and then we want edn read string. So we have this. After that, we want to get our cookie store key, and there is a function byte array to convert it back to byte array. So if we get this block and we just pass it here inside the key, and now that should work. So we need to log in first, then we refresh here, we have the session. If we, so we have the session. If we restart the app, I'm reloading it, it should still work because the key is the same, so we can decrypt our cookie information. So couple other options on the wrap session level. So we have these params that we can set. It should be in cookie attributes, and then we have this map, secure true. Let's restart. Let's reset the cookie. So if we go here, now we have this secure true, as you can see, secure true. And by default, it's enabled, it's set to true for the HTTP only, which is good. And the other thing is this expire or max age. So now we have session, so it's kind of like a short living session. So to fix that, we can do max age here. And for example, it's in seconds, I believe. So we can do like 60, so it will be a minute and like 10 minutes, or how long you want. If we reload and refresh in the cookies, now we see that it's not session anymore. And now we have the expiry date here, which is 10 minutes from what we have now. And also, if you don't want to stick with the default cookie name, it's possible to say cookie name here and say whatever you want, like my Clojure app session cookie. Refresh, and let's set the cookie once again. And now we have this cookie that will be used for the session with our new custom name. So potentially, the downside of the approach when we use the cookie store, so we basically encrypt cookie session data, put it in the cookie, send it to the client, and then the client send this information back all the time, is if your cookie grows more and more, this should be included in all requests from the browser to your backend. So we're basically increasing the payloads. So the other option is to use different cookie stores. So as I said, there are two included, but the protocol looks like this. And if you want your custom store, you basically implement these three methods to read session, write session, and delete session. One of the real-world implementations of that, if you have your relational database, you can use this JDBC ring session, which basically implements that protocol, and you can use it as a replacement of these stores. So you need to do a bit of setup. So for example, if we're using Postgres, we want to create a table with this format. So it will have this session ID, which will be a cookie information, cookie key. And then we have the value, and the value will be serialized with NIPI, your session data. So it's basically stored in the database, but in like a serialized format. And this will do it for you automatically. Good thing as well that there is a session cleanup. So you can run a separate process that removes rows from the database based on the session timeouts. So if we want to invalidate our session cookie on the backend, we can do that, and it will delete the row from the database as well. But I guess we'll not cover this today, and it will be better to implement the entire user login flow with the database in the backend in the next video. So if you don't want to miss that, subscribe to the channel. But I think that's it for today. I hope you got a good understanding how cookies and sessions works in Clojure and how to implement your user login flow. Thanks again for watching. Please like and subscribe, and see you in the next video. Bye bye.